Welcome to Network Professionals. Hello everyone, welcome back to our channel Network Professionals. I'm engineer Javiria Oftab, Cisco certified instructor. In the last lecture, we discussed chapter 5. Coaxial cables. Coaxial cables are a type of copper-based network cable used mainly in older networking systems and for television signals. Here's what you need to know. Construction. Made from copper or aluminum as the core conductor. Surrounded by insulation, metal shielding, and an outer jacket. The shielding helps reduce signal interference. Uses. Commonly used in cable TV systems, satellite communication, some broadband internet setups, older computer networks. Pros. Better shielding against interference than twisted pair cables. Suitable for long-distance signal transmission. Cons. Harder to install due to its thickness and stiffness. More expensive compared to twisted pair cables. More difficult to troubleshoot. Twisted pair cables. Twisted pair cables are the most commonly used cables in networking today. They consist of pairs of wires twisted together to reduce interference. There are two main types: unshielded twisted pair, most commonly used in LANs, local area networks. Contains 4 pairs of color-coded wires twisted together, prone to interference from nearby electrical devices, such as EMI, electromagnetic interference, and RFI, radio frequency interference. Less expensive and easier to install. Shielded twisted pair includes extra shielding, foil or braided wire, around the wire pairs. Better protection against ME and RFI. More expensive than UTP. Harder to install due to extra shielding and thickness. Twisted pair category ratings. Twisted pair cables are classified into different categories, CAT, based on their performance, speed, and frequency. These ratings help determine what type of cable is suitable for a specific network. Common twisted pair categories: CAT 5 UTP, unshielded twisted pair. Speed, up to 100 megabits per second. Bandwidth, up to 100 megahertz. Used for fast Ethernet, 100 base TX. Older standard, not recommended for new installations. CAT 5e UTP, enhanced category 5. Speed, up to 1 gigabit per second, 1000 megabits per second. Bandwidth, up to 100 megahertz. Improved performance with less crosstalk, signal interference. Widely used in modern LAN networks. Supports gigabit Ethernet, 1000 base T. CAT 6 UTP. Speed, up to 10 gigabits per second, for shorter distances. Bandwidth, up to 250 megahertz. Tighter twists and better construction for higher performance. Supports 10 Gbps Ethernet, up to 55 meters. Good for high-speed and future-proof networks. Twisted pair wire schemes. When creating a network cable, it's crucial to follow a consistent wiring standard at both ends of the cable to ensure proper data transmission. This means that both ends of the cable should use the same wiring scheme. There are two common twisted pair wire schemes: T568A and T568B. T568A and T568B wiring standards. These standards define the order of the colored wires inside a twisted pair cable. Both standards provide the same electrical performance, but they use a different color sequence for the pairs of wires. T568A standard, less common: pin 1, white, green. Pin 2, green. Pin 3, white, orange. Pin 4, blue. Pin 5, white, blue. Pin 6, orange. Pin 7, white, brown. Pin 8, brown. T568B standard, more common: pin 1, white, orange. Pin 2, orange. Pin 3, white, green. Pin 4, blue. Pin 5, white, blue. Pin 6, green. Pin 7, white, brown. Pin 8, brown. Straight through versus crossover cables. Straight through cables. Used to connect different types of devices, such as a computer to a switch, or a switch to a router. Both ends of the cable should use the same wiring scheme, either T568A or T568B. Crossover cables. Used to connect similar devices, e.g., computer to computer or switch to switch. One end of the cable is wired using T568A, and the other end uses T568B. Fiber cables and connectors. Fiber optic cables are a crucial part of modern networking, offering high-speed data transmission over long distances. These cables use light signals instead of electrical signals to transmit data, providing much higher speeds and reduced interference compared to copper cables. There are two main types of fiber media used in networking. Types of fiber media. Single-mode fiber. Core size. Single-mode fiber has a very small core, typically around 8 to 10 microns in diameter. Technology used. It uses laser technology to transmit data. A single beam of light is sent through the core, making it ideal for long-distance communication. Distance. Single-mode fiber is capable of transmitting data over longer distances, often several kilometers, without signal degradation. Use cases. This type of fiber is used in telecommunications networks, long-distance connections, and high-speed data centers where distance and speed are critical. Multi-mode fiber. Core size. Multi-mode fiber has a larger core than single-mode fiber, typically around 50 to 62.5 microns in diameter. Technology used. It uses LEDs, light-emitting diodes, to send light through the core. The light travels through the core at different angles, which can cause light to bounce off the walls of the core, modal dispersion. Bandwidth and distance. Multi-mode fiber offers high bandwidth, up to 10 gigabits per second, but is limited to shorter distances, up to 550 meters. The light signal loses strength and clarity over long distances due to the multiple paths it can take inside the core. Cost. MMF is generally cheaper than SMF and is used in local area networks, LANs, data centers, and other medium-distance applications. Fiber optic connectors. Fiber optic connectors are used to join fiber optic cables to devices such as switches, routers, or fiber optic patch panels. These connectors ensure the smooth transmission of light signals through the fiber, maintaining signal integrity. There are several types of fiber optic connectors, each with unique characteristics and use cases. Below are some commonly used fiber optic connectors, ST connectors. Design. ST, straight-tip, connectors are one of the older types of fiber optic connectors. They feature a bayonet-style coupling mechanism, meaning they twist and lock into place. Usage. Primarily used in single-mode and multi-mode fiber installations, particularly in older networking setups. Advantages. Simple to install and use. Secure connection with a twist-lock mechanism. Common applications. Telecommunications, legacy networks, and other environments where fiber optic systems were set up years ago. SC connectors. Design. SC, subscriber connector. Connectors are square-shaped connectors with a push-pull design. These connectors are widely used for high-density applications due to their simple and secure mechanism. Usage. SC connectors are suitable for both single-mode and multi-mode fiber cables. Advantages. Easy to install with a simple push-pull mechanism. Often used in data centers and high-performance networks. Common applications. Fiber optic patch panels, LANs, and high-density setups. LC connectors. Design. LC, lucent connector. Connectors are smaller than SC connectors and have a latching mechanism similar to that of RJ45 connectors, making them ideal for high-density applications. Usage. LC connectors are typically used in single-mode and multi-mode fiber optic cables, especially where space is limited. Advantages. Smaller form factor for high-density installations. Cost-effective for large installations. Common applications. Data centers, telecommunications, and high-density environments like fiber optic patch panels. Duplex multi-mode LC connectors. Design. Duplex multi-mode LC connectors are used for dual fiber optic cables, both sending and receiving signals. They feature two LC connectors that are paired together to facilitate full duplex communication. Usage. These connectors are used in multi-mode fiber installations and are ideal for applications where two-way communication is needed over short distances. Advantages. Enables duplex communication, both send and receive on separate fibers. Compact and space-efficient for high-density installations. Common applications. Data centers, Ethernet connections, and other high-speed networking applications. Thanks for watching. Subscribe our channel Network Professionals for more informative videos.